All right, let's talk about something pretty much every Python developer runs into at some point. Have you ever written a function that just acts weird? Like it seems to remember what happened the last time you ran it? Well, we're about to dive into one of Python's most notorious little traps. It's all about default arguments, and it has baffled so many of us. Today we're going to pull back the curtain and see exactly what's going on.
And it all starts with this feeling, right? A developer named Timothy put it perfectly. You write what you think is a simple function, but when you run it a few times, it's not starting fresh. It really does feel like data is just leaking from one call to the next, and honestly, it can be incredibly confusing.
Okay, so let's look at the culprit. Here's the code causing all the trouble. We've got this simple function, addStudent. It's supposed to take a name and, add it to a list. The first time we call it with Alex, everything looks fine. We get exactly what we'd expect, a list with just Alex. But then, look at that second call. We pass in Alice, and instead of getting a new list with just her name, we get a list with both Alex and Alice. What is going on?
And that really is the million-dollar question here. The default is an empty list, empty brackets, so why on earth isn't it starting fresh with every single call? The code looks like it's promising us a new list each time, so what's happening behind the scenes? To solve this little mystery, we have to kind of change how we think about this function. The problem isn't that it's forgetful, it's actually the opposite. This function has a memory, and understanding how that memory works is the key to solving this whole thing.
So here's the first big clue. It all comes down to timing. The entire problem boils down to one simple question. When exactly does Python create that empty list that you see in the function definition? The answer is probably not when you think. And here's the answer. Python creates that default argument object only once. It happens at what we call function definition time, that split second when your program first reads the def addStudent line. In that moment, it creates the function object, it creates a single empty list, and it attaches that list to the function itself forever.
So this is the big disconnect between what we think is happening and what's really going on. Our intuition says we get a new, fresh list with every call. But what Python actually does is create that list just one time, and then it reuses that exact same object for every single call that doesn't provide its own list.
Okay, so that's a pretty convincing theory. But can we prove it? Can we actually find this single, persistent list that's just hanging around inside the function? Let's do some detective work and see if we can expose this, well, let's call it a zombie list.
And luckily for us, Python actually lets us peek under the hood. Every function has a special little internal attribute called __defaults __. It's basically a tuple that holds on to the default argument objects that were created when the function was first defined. This is our smoking gun.
Now, check this out. Before we even call the function a single time, we can inspect its _defaults _. And what do we see? We see a tuple, and inside that tuple is our empty list. This is proof positive that the list was created and stored the moment Python first read that def statement.
And here is the aha moment. After we call the function just once with Alex, we inspect _defaults again. And look, the default object itself has been changed. It's not empty anymore. This proves we're modifying the exact same object that's living inside the function definition itself.
So that zombie list analogy really fits, doesn't it? It's created once, it attaches itself to the function, and it just keeps coming back with every call, carrying all the changes from the previous runs. It never gets a fresh start.
So, we figured out why this happens. But the real question is, how do we stop it? Well, thankfully, there's a simple, really elegant solution that all professional Python developers use to avoid this trap. Let's take a look at the standard practice.
The core idea is simple. Never, ever use a mutable object, something that can be changed, like a list or a dictionary, as a default argument. Instead, you always use an immutable value. The go-to choice is none. It acts as a safe placeholder, which then lets you create your new list fresh inside the function body every time.
And here's what that fix looks like in practice. Notice the default is now student list equals none. Then, inside the function, we have a simple check. If student list is none, then we create a brand new totally empty list. This logic runs every single time the function is called, guaranteeing a clean slate.
This is a pattern you can and should use everywhere. It's just 3 easy steps. Number 1, set your default to none.
Number 2, check inside the function if the argument is none. And number 3, if it is, create the new object you need right then and there. This pattern completely solves the problem.
So, to pull this all together, let's look at a quick summary. You can think of this as your cheat sheet to help you remember the rules and avoid this trap in your own code.
This table really says it all, doesn't it? Your safe defaults are anything that can't be changed. None, booleans, numbers, strings. The dangerous ones are the mutable objects, lists, dictionaries, sets. The core problem? Defaults are evaluated just once. The solution? Always default to none. And if you ever get stuck, your debugger is __defaults __.
And that's pretty much it. We've uncovered how Python's default arguments really work and, more importantly, how to use them safely. But it does leave you with a final thought, right? Now that you know about this particular trap, what other subtle behaviors or zombie variables might be hiding in your own code, just waiting to be discovered?